Welcome everyone, and thank you for taking the time to join us today to learn how Nephos and Scality are working together with new technologies to optimise your Splunk infrastructure. Joining us today is Lee Biggendon and Brad King. Lee is the COO and co-founder at Nephos Technologies, who are a key strategic partner for Scality. Brad is co-founder and field CTO at Scality. Today's session will last approximately 30 minutes, and you can submit your questions via the platform at any stage during the presentation. We will address them at the end in a Q&A session. So without further ado, I will hand over now to Lee.
Well, thanks for the intro, Luke. As Louis said, my name's Lee Biggendon. I'm the co-founder of Nephos Technologies. We're a UK-based data services integrator. Today, I'm going to be speaking to you a little bit about Splunk and how we're helping clients to optimize the infrastructure that lives on. Before I get into that, though, I'm going to give you a quick introduction into Nephos and who we are. Try and keep it brief for you. We've been around for about 8.5 years now, and we're a specialist data services integrator. And our focus really is to help customers to solve what we believe are complex data problems, and that's across 3 key disciplines really. So data storage and processing, data privacy and governance, and lastly data analytics and data services. We've been very successful in that sense, so very strong growth, very strong customer retention rate, and we put that down really to our independence, our kind of consulting-led approach to helping our customers to develop and deliver on these strategies. And that's been key for us over the past eight or so years. And that's led us to be very successfully trusted by some of our key customers across various different groups. Now, without going into detail about them, the thing that kind of binds them, if you like, is their reliance or their drive to get more from their data and to leverage data across their business to drive value. And when we look at that kind of data profile, if you like, it's kind of everything these days, right? I mean, most people are using it to drive value in one way, shape or form, whether it's Genomics England that are processing genome sequencing data, whether it's a retailer looking at customer insight, whatever it might be. It's key to most things. And when it comes to driving value from that data, Splunk is becoming pretty much a de facto standard for analytics and IT ops management. I think that recently I saw that they're now being utilized by something like 91 out of the 1,100. So that's really quite a strong position for them to be in. But an inhibitor quite often is the underlying infrastructure and the impact that has on the complexity and the cost of managing those data sets. Now, Splunk's no different to other platforms in as much as it's data hungry, right? And it requires processing power to be successful. And that's quite often where we see customers have challenges, and it's quite often where we will work to support our clients to kind of optimize that infrastructure. And that's what we're going to talk a little bit about today. So the first thing that I'm going to touch on here is around some of the challenges that Splunk has in general, from an infrastructure perspective, not as a platform perspective, obviously. Ultimately, we all want to store and process more data, right? And we want to do that without an impact on performance, without a slowdown in time to value from our data. And those data sets are growing day by day by day. And that puts a lot of strain on the infrastructure itself. Now, historically, when we design an infrastructure to support Splunk, most of those indexer environments kind of started life as physical dedicated servers, right? Now, over time, as those deployments grow, the infrastructure itself quickly becomes quite cost prohibitive, when you're putting it on that kind of platform. So what people were doing was kind of driving towards two things really. One virtualization. So how do we virtualize that performance tier so that actually we can scale it a little bit more dynamically, so that we can not create more silos and pockets of infrastructure. So that's one area. And the other piece to overcome a lot of the performance challenges or the performance requirements that organizations had when processing this data was kind of a move towards all-flash array. So, you know, we're starting to put in quite a complex, quite an expensive, virtualized all-flash platform. And historically, all of that data has been stored on that one single platform, right? As you scale and as you want to grow the data sets, it's really tough to manage that, both commercially and operationally. So actually, this growth in data has quite a significant impact. When you add to that as well, one of the big wins that all flash arrays give you, generally speaking, is their ability to compress and dedupe data. You know, typically inherent within most of these platforms. Problem is that Splunk pre-compress that data, so actually you don't get the level of dedupe rates or the compression rates that you would expect from a normal infrastructure. So again, we're kind of suboptimal in that state. So the challenge is how do we give ourselves a platform that can ingest all of that data, that can meet those performance demands and those scale demands, but without breaking the bank and without making it overly complex. So that's a big challenge, right? The other thing to consider here is that most of the data that's really stored in these systems is static. It's cold. You know, quite often 70–80% of the data, once it's processed, is effectively there for longer term retention. So it doesn't actually need to sit on something that's high performance, high IOPS, really. We've done it because it's simple to manage, that's why. And tiering wasn't really an option historically. So that's a big problem for us to scale and grow these things, and we want to optimize that, right? When we look at the infrastructure itself, if we look at the workloads, as I just mentioned, in a lot of cases, the bulk of the data is static, right? Now, what we tend to find is that if you look at the performance requirements and cost requirements, we all know this, that the more performant the system, the higher cost it comes with, because, you know, that's effectively what you're paying for. But putting what is cold static data on something that's really high performant and quite expensive doesn't make a lot of sense these days, particularly when we've got other options in terms of object platforms. What things like object also give us is the ability to scale that platform almost without limit, right? We don't really have any restrictions in terms of how far or deep an object platform can store, because we don't have the limitations of replication rate typically. So actually, when we look at the balance of the data that we're storing and the kind of look and feel of that data against the infrastructure itself, there's a bit of a mismatch. We need performance for the indexers in a Splunk environment, absolutely, but not all of the data that we're storing needs to live there. We need scale and we need depth, which actually is more suited where we've got that kind of 70–80% of colder data to an object here. So what we're doing and what we look to do as an organization to optimize that is to create more of a blend. So rather than go put all of the data on all flash or all of the data in a high performant tier, what we look to do is create more of a blend, right? That's what we're hoping to do. The first thing to touch on there is that virtualized layer, that performance layer. So just to take a quick look at how we do that, you know, in 2019, I think it was now, Splunk kind of accelerated their development in terms of architecture and support of container services. So the ability to support Docker, Kubernetes, et cetera, has evolved quite significantly over time. So what we're looking to do is, rather than rather than deploy quite expensive virtualized infrastructure that still has some challenges when it comes to scale out. What we're looking to do is leverage, in this case, Kubernetes to deploy the various performance aspects of the Splunk infrastructure, so indexes, search heads, all of those kind of things, on a performance scale-out Kubernetes platform, all as individual scale-out pods. So effectively what we're able to do there is to, as I say, independently scale out and up each of the various aspects of the infrastructure in line with demand and do that more dynamically. Quite important when we want to drive more performance out of our data and be a bit more on demand with it. It also gives us the ability to make those workloads more portable. So, being able to move infrastructure as we need to, whether that's in cloud or cross-platform or whatever it may be. And it also gives us a more dynamic infrastructure operationally so that we can upgrade, develop, change as we need to. From a performance perspective, what we've seen here by taking this approach is kind of a 2.5x performance gain against Splunk recommended rate for hardware config. We've actually seen if you take the same approach and deliver it in cloud and deliver that on EKS within AWS, we also see a 61% performance gain there, as well as it's quite significant cost reduction. It's about a third of the cost overall of doing that. So what we believe this gives us is one, a cost reduction play, which is great, and we all definitely are looking for that in the current economic climate, but also the ability to scale that more linearly and more in line with demand. So that's really, really important for us. That's the first piece when we look at optimizing. The second piece that we look at is around some of the new capabilities that Splunk brings us in terms of being able to offload that colder data. Now, for long-term retention, where we have that cold data, within SmartStore now, we're actually able to make the indexes effectively stateless. So effectively using them as a caching layer, copying that warm data down into an object tier using S3. And then the data stored within that warm tier is kind of evicted, if you like, from the performance tier by new active data sets. So we've got a more dynamic, almost caching approach to the way that we process data. And in line with that, it means we can be a bit smarter about the performance tier. So, we don't need so much of it, where we've got quite a high cost per gig equivalent. And what we can do is then leverage the lower cost per gig, bigger scale, more depth object here below it for long-term data retention and greater data availability. All of that without replication and rate. So, realistically, we're making that data a lot more durable. That's kind of the combination we're looking to bring in terms of optimizing these things. And with that, what I'll do now is hand over to Brad and to talk a little bit through the object storage layer and how Scality support that within clients.
Very good. Thank you, Lee. I think you could ask yourself why object storage? Why does that make sense in this space, and how does it help out? I think I'll talk a little bit about Scality as we go along, but I think we have all these stories about data is the new gold. And I think one of the key things about data being used in an environment like this with Splunk is that almost invariably the data that's being analyzed is the result of human actions. Whether it's a banking application, a travel application, a email application, it's been Splunk has been very popular in logging human activity, in analyzing human activity. And so you have this data that you can't simulate in another way. It's real things that happened in the real world. So there's a pricelessness to it. It's irreplaceable. And experiences or incidents that happened on your system are things that that can't be artificially reproduced. So you have data that may have information in it that has extremely large value, and you don't necessarily know as you're storing your data away. So this presents an interesting problem. Maybe there's a lot of value in that data. We're not sure yet. And it's some another thing that's been happening over the last 3 or 4 years is the algorithms to find valuable insights in data, to understand trends, to understand the whys of incidents that happened, and do troubleshooting. So many of the things that we do at Splunk, new algorithms are coming along all the time. We're getting better at understanding how to use our data. And so you have this problem: should I spend money on saving my data? Should I not? If it's too expensive, the answer is, well, I just can't. It's not even a question. But if we can afford to save the data, then I think there's a pretty strong movement afoot to say, yes, let's save some more data. We might be able to get meaningful insights out of it. And this transition that Splunk has allowed people to start thinking about keeping a lot more data, something that wasn't possible a few years ago. I've had experiences of talking to some of our customers saying, we love Splunk, but we never have enough of our data sets to do what we think we could with the data. So, okay, let's say object storage is less expensive. That means we can retain more data, but retaining more data has its own set of risks. Having more data means just a mathematical increase of the risk of losing data. The longer you retain data, the more the risk is of losing data. So you have to do better protection than, as Lee mentioned, than traditional RAID. You incur risks by storing larger quantities of data, and even losing some of your data that may be very important, because the more you have, statistically, just the risk goes up. So more economical storage, better data protection, those are really things that object storage excels in. We've used erasure coding schemes for a long time to give very high levels of protection to data, and that's something that's very interesting for these large data sets. Being able to protect the data, very often we have environments where doing backup of multi-petabyte systems is just simply impossible. And sometimes these systems, the data rates are changing so fast that backup is completely unrealistic. So these challenges of longer retention, high value data can very much be met by object storage. But okay, we move the data to a colder tier. We have this historical data and we push it off to a colder tier. But the question historically has been, well, okay, how cold is too cold? If my data is all stored away in some place that I can't really get at it the way I did with the hotter data, its value fundamentally drops. It seems to make obvious sense that data that's least frequently analyzed, and Lee presented that very well, doesn't need to be on fast storage. At the same time, if we can't really do anything useful with it, then it becomes, again, useless data. It's too cold. Frozen data is not particularly interesting. And I think that's one of the key things that this new Splunk architecture provides, is the ability to keep data searchable, findable, if you like, so not too cold and not too hot, kind of a Goldilocks situation. We've had experience with customers who've tried to use Splunk's ability to look through cold data and find information in it without it being indexed. But the experience there is that it's just too cold. It takes too long. It takes too much I/O on the system. So you kind of have this binary problem. Either your data is cold and it takes forever to get your information out, or it's hot and it's too expensive. So this is really the sweet spot that this new SmartStore application makes. Keeping, as Lee mentioned, this maximum flexibility, but able to retain the search performance. And that's one of the things that Splunk has really made a lot of progress in having application-aware caching, understanding what of the data is most likely to be accessed, and the less frequently data can be automatically pushed off to an object store. In the end, you have the speed of the analytics that everyone loves about Splunk, but the ability to have those analytics applied to a much deeper data set, so you can see more trends. You can develop this, what everyone's talking about, the true value of your data, and you can begin to think about saving data for periods of time, doing new things that you never thought possible before, and obviously the cost goes down. The impact of indexing maintenance is better, and your data integrity of that large pool of data is protected using the algorithms that object storage platforms are so effective in. And Scality has some very unique possibilities in very highly protected geo-distributed and geo-replicated systems that are used fairly frequently. So in the end, what are we proposing? Combining, as Lee mentioned, object storage of Scality Ring together with Splunk. We have a number of platforms already deployed around the world with this environment. We actually started doing this before SmartStore was available, having platforms that mounted a Scality Ring, presenting object storage as a file system rather than an S3-like interface to the backend system. We have a platform that's ingesting over a petabyte a day of new data into the platform, and the indexes are available to be searched. We also support and are fully compatible with the new SmartStore model, and we have platforms that are doing the same thing, over a petabyte of data being ingested on a daily basis in the banking industry, and being able to do Splunk analytics on a massive pool of data. In so doing, we reduce the overhead from the typical 3x replication of a Splunk platform, or possibly the less safe RAID on the disk, to about a 1.4 overhead raw to usable data. We can use very large 4U servers, and so you get the operational cost of storing your data becomes a much less significant issue. You just have to worry about keeping your Splunk cluster up and running. So you get overall reduction in cost. You get analytics on a much richer set of data, and so it's really a win for everyone involved, and you really begin to profit from this whole experience of having a very large pool of data. And we're seeing this really taking off now as the transition with the SmartStore functionality of Splunk making this all possible. I'll pass it back to the lead to explain some experiences that we've had with this.
Brilliant. Thanks, Brad. That's great. So as we close this up, the last bit that we wanted to touch on really was kind of, what does it mean in real terms? What does it mean? And I mentioned at the top, we're quite a consulting-led organization. One of the things that we do with clients is work around our SmartData storage offering, which is in essence an engagement that enables us to help develop roadmap and strategy around the adoption of kind of new infrastructure techniques like these. So that's pretty key for us, and a lot of what we do as part of that is to work on, one, the technical approach, but also the business case around it. And that's what I'm just going to touch on now. So what you'll see right now is a couple of models that we ran through based on 120 terabytes worth of usable storage, with kind of a day one cost and a 3-year cost forecast, if you like, from TCO perspective. In the first instance, is a traditional deployment model. And then we've run 2 alternative models there, one with that infrastructure optimized with containers on their own, and the other with it optimized with both containers and object platform. And what we've seen through the numbers is a 66% reduction in the indexer infrastructure. So by leveraging containers and some quite performant infrastructure there, but on a smaller footprint, we've seen quite a significant reduction in the actual indexer infrastructure that's required for that environment. And we're also seeing an 80% total cost of ownership reduction if you consider platform optimized with both containers and objects, against putting all of that data in a single performance tier as we would do traditionally. So there's quite a significant benefit, both from a physical infrastructure perspective, from a cost perspective, of taking this approach, but also, as Brad mentioned, the more data we can store in these platforms, the more we can index, the more we can search, the more value we can drive from it as well. So where we see customers really trying to take advantage of this is, we don't want the underlying infrastructure to inhibit what we're able to take from these platforms, right? We don't want to have to limit our capability in terms of analytics because the infrastructure is expensive. So if we can find a new way of doing that and a different model, then that's going to free us up to drive more value from our data, and that's really where we're looking to drive there. I think that kind of concludes things from the overall presentation perspective. So I'll just hand over to Louise to pick up questions that may have come through.
Thank you, Lee. Yes, we've had a few that have been submitted. We can still take questions through the facility on the platform, but we've got a few that have come in so far. So first of all, why can't I do the same thing in AWS?
So I'll pick that up, Brad. You can, is the honest answer. You absolutely can. The question is whether you want to or not. And what I mean by that, I think we've seen this with customers for sure, and there's also been some independent research papers that we have that compare and contrast the two models. And I think there's a couple of elements that you need to consider. That the first is around the ongoing cost of doing that. We would typically expect the on-premise model to, over 3 years, run about a third of the cost of delivering the same thing in AWS or Azure for that matter. So that's the first element. So the ongoing cost model is an issue. The other thing that we have seen is that on some performance benchmarks, we've actually seen a much better performance gain on some more dedicated on-premise Kubernetes platform rather than in the AWS environment. And likewise on ingest rates. So we've seen on-prem top out at 5.5 to 6 terabytes worth of throughput versus 2.5 within AWS, and we've got those papers, so we can make those available if you want to drop us a line after. We can make that data available for you. But that's why.
Maybe just as in a small additional comment, I think one of the questions that needs to accompany that question is, where is my data being produced? If my data is being produced in a public cloud, then running this kind of an architecture in a public cloud probably makes more sense than if your data is being produced on premises or on a remote site somewhere. But keeping data has probably the most inertia as far in a system like this. Moving your compute around is very easy. Moving your data around is very time consuming. There's no faster way to move data around than putting it in a truck. And so I think if you've got a lot of data that's being generated, getting it to a public cloud, if it isn't there already, can be a real challenge.
Thank you. Next question is, Kubernetes is a concern for us. as there's no support structure to it. What do other customers do to overcome that, please?
I guess Kubernetes in and of itself, yeah, absolutely. But there are, I guess, productized versions, if you like, that can be delivered on with kind of enterprise level support. So, your traditional 24/7 support model that you get from most vendors today already on other platforms. So I think over time, I think people have realized that actually that's a bit of a limitation for adoption, generally speaking, on any platform like that, really. So there are more and more vendors out there. We work with some of them. Some of the mainstream providers are doing this already, the likes of HPE and whatnot. So where they're kind of supporting that on your behalf and providing that kind of enterprise grade support. So we're seeing that actually as less of an issue these days. The other option that we're starting to see more commonly is people looking to take this stack as a managed service to try and alleviate some of that risk. I don't know what you're seeing, Brad, but that's definitely what we've experienced.
I think what we're seeing is this is changing, kind of as you mentioned. I think Kubernetes is definitely got wind in its sails, and we're really this is early days, I guess I would say, and we're seeing more and more companies that are getting more comfortable with Kubernetes. But it has definitely been a problem, and I think we're going to see that problem disappearing. I think 2 or 3 years from now, having Kubernetes infrastructure is going to be as simple as having a VMware infrastructure in people's minds, at least. Maybe even a year from now, I'm not sure, but.
Yeah.
We'll have one final question because we're running out of time. What kind of scale is realistic? We have a lot of data.
Yeah, I just one comment there. I think we see this in the whole space of machine learning, artificial intelligence, analytics, be it Splunk or other technologies, and there's always this balancing act between how much data makes sense and how much data is practical. I think we have seen that some of our customers have so much data that if you can't handle the scale, they can't do the analytics that they want to. And I mentioned a couple customers we have that are ingesting over 1 petabyte of data a day. That's kind of an insane amount of data, but it's the reality of some of the needs. So I think how big is too big is a question of your budgets and what's meaningful data. I think what we've seen with our customers that are able to keep a little bit more data is that seeing trends, seeing things like that, it's really useful. I think one of the challenges is you start with a certain amount of capacity, and I think that's the great thing about this model. With an object storage platform, with a Kubernetes-like infrastructure, the question doesn't have a brick wall that you're going to run into. If you're getting value from the data, you can grow your platform. And I think we have platforms today that are running in the 20, 30 petabyte range, ingesting, and that would be only a month of data in a sense at petabyte a day. But I think the great thing about this new model that Lee presented is that there's no hard limit to how big your system can become in the end if you're getting value out of your data. Obviously, if you're not getting value out of your data, your system is too big. But
thank you, Brad. So that's the end of our session today. Thank you all very much for your time and for joining us on this webinar. If you have any questions, please do get in touch. The contact details are on the screen in front of you, or you can contact us via the Scality website. Thank you very much, everybody, and goodbye.